Hello viewers, welcome to my first video on my second channel. And why I've made a second channel is there are two reasons for. The first reason is I want a dedicated channel for the more detailed electrical or detailed electronical videos. I saw that the electronical repair videos on my main channel are not the most popular videos, so some of my viewers are not interested in that. Therefore, when you follow my main channel, you won't see the electronic videos again. And if you want to see the electronic videos, you can follow this channel and I can make more detailed electronic videos, a bit more separated. And the other reason is maybe I will make some videos that are more loosely related to the topic of my main channel. So my main channel is mainly about VAX and alpha and titanium and from Digital Equipment Corporation or the legal successors or Compaq or HP, and also about OpenVMS, network stuff and WAN and stuff like that. So that will be remaining on the main channel. On that channel I will make other loosely related things like telecommunication and restoring papers and stuff like that. So yeah, this is the reason why I've made that channel. Yeah, and one of my last videos on my main channel is a video about this power supply. You can see over here. I've tried to repair it and it wasn't successful and it won't work also at the end of that video. So yeah, this is more pre-talk to that what you've seen after this introduction. You will see scenes recorded several weeks ago because after I released the first repair video on my main channel, I did some other things as well, but they weren't successful, but you will see them later. And I've also tried out other things, so I've tried out to run the machine without the hard drives to reduce the load of the 12-volt rail. I've tested the vans externally, and quite interestingly, the vans need about 50 watts in total. That's a lot for two vans. But there's no problem with the vans, no problem with the 12-volt rail, no problem with the hard drives. So the problem is still inside this power supply. Yeah, but now I will show you what is the issue with the power supply. When you want to see the previous video, you found it on the main channel. I will link it also down below. I will link it also down below the main channel where all my main content is released or will be released also in the future. So have fun with that video. Yes, I did some further investigations on the power supply and try to understand how that power supply works. And there were some really interesting things I discovered. So last time I talked about this 5-volt board over here, and I will show you some parts. Here on the macro, I see we've replaced these two capacitors over here, and I've did some investigations on the board. And I found out that these two capacitors are only responsible for the 3.3 volt rail. So these are the filter capacitors of the 3.3 point rail. But when you have here, look on the left, over here, there is no filter capacitor on the 5-volt rail. So this is really interesting. So this is a transformator, and here are the rectifiers, and here some shunts and another transformator, and only here are 3, and here the bottom are 3 SMD capacitors as well, but there are no capacitors for the filtering, no electrolyte capacitors for the filtering, and at the moment I really do not understand how the filtering works. But then I had a look at this board over here. This is the board with where all the logic is located, and also some other parts, and this was really interesting, because here you can see here are 7 capacitors, so I'll show you it on the macro as well. To the left. Here are 7 capacitors with 470 microfarad each. And you can see here, this transformator here, there's a transformator. So on that board is a whole secondary side and a whole switching power supply switching part for the power supply as well. So this transformator over here is another switching power supply and another part that switches. Here this is the switching transistor, and here this is a transformator, and this is here a rectifier and filter capacitors. So here that line, this is the distance, this is the relation between the primary side. So this is primary, this part over here, this is primary, here the transformator, here comes, this is the input from that board from the mains, and then here are some filtering, and there are another filter capacitors on the board, previous board, and here is you can see it maybe that here is some kind of isolation on the board, and these two cables are the cables connected to the 5V and the 12V board, and here there is a transformator and some switching parts. So last time I said that I don't know if the logic will work without the 5V board, but the logic will work without the 5V board because there is has its own transformator and its own switching unit in the power supply. But I really do not understand why here are so much filter capacitors with 470 microfarads on the secondary side of the logic board. The cable here, the cable that goes to the 5V board, I think this is the cable, yeah, this cable goes to the 5V board. There are only two cables, these are two cables here inside, and I think this is the power for the primary side of the 5V board, and here are 5 more cables. The black one is ground, and this ground is also connected to the secondary ground of the backplane, and you can see this is located here on the secondary side, and these cables over here I think are for the switching controls, because I will show you that board again. Here on that board there is no feedback for the switching. So here's the secondary side, but no feedback how fast the two MOSFETs located down here, on the other side, these the MOSFETs here, how fast they have to switch, and this board over here is also secondary side, so the primary side is inside and the secondary side goes around the primary side. So this board over here is connected to the connectors here, which goes to the secondary side of that board, and only the two the power from the primary side is located over here, and that goes to some kind of filtering, and then to the MOSFETs, and then to the transformator for the 5V and the 3.3V rail, and I think it's on the 12V rail it is the same. But that does not explain why here are so much filtering capacitors. And I measured the lines, I think the grounding is connected, but there is no connection between the 5V on the 5V board and these some of these lines over here. So I do not know if the 5V is filtered or by that via the backplane. So this connector over here, this connector goes to the backplane with all the measuring connectors, etc. But then the 5V has to go into the backplane, and then via this connector back into that board uses that filter capacitors and then goes back. This is really weird, but at the moment I do not understand how this filtering of the 5V rail works. But nevertheless, I did some other investigations on that board, so I had a closer look on the capacitors. And you can see a capacitor over here. I'll show you that capacitor in the macro. The macro has only manual focus, so it takes a while. This brown capacitor over here. On the other board, this capacitor completely leaked and it was completely broken, and also damaged a bit of the board. I can show you later, but the other board is here on the right. And I think this was the reason why the other logic board does not work at all. So what does this capacitor do? Here this is the transformator for the power of the logic, and there is you could say a secondary part, but the secondary is connected to the primary side for that thing. So this is a small rectifier. So here's a small diode. It's a easy circuit. This is a diode, and after the diode is this filtering capacitor. And this filtering, I think these components are the power supply for the parts over here. A bit more here. These parts over here, this is primary side located. I think this is the control of the switching MOSFETs, not only this one, maybe also other MOSFETs, but maybe the switching MOSFETs of the other board are also controlled by the secondary side. That's the thing I don't understand, because there are, I think there is some kind of isolation between it, and also here and here are two optocouplers, and on the other board there are no optocouplers. There's one optocoupler, and the other optocoupler is somewhere else. I think there's a second one, but there is a second one. I know that there are two optocouplers between. Where is the other optocoupler? Have a look at the other board, which is a bit. Yeah, the other one is here. Yeah, there is the other optocoupler. There is the other optocoupler. there you can see it. So so there can be some information yeah, transferred from the secondary to the primary side, electrically isolated. Yeah. But yeah, I will check that capacitor on that board. This is a board from the power supply I've worked on in the last video, and I will also check these 7 capacitors over here. On the other board, 1 leaked, but I've measured them with the LCR meter. All 7 capacitors were okay, but also 1 leaked. And this, I think this one is maybe, could be, it's not, maybe you can see it, this is a problem, optical problem, so maybe there is a problem with the capacitors over here as well. But there is another thing I've had a look at. I think this is quite hard to show. Also with the macro camera. Second, I think I can't see it. Here, this is the connection of the ground, and there is a metal ring around around the part where the cable is soldered to the circuit board, and this is quite loose, and maybe the distance between the ring and the next part became low, and then when the system gets warm, this is too low, then there is some kind of isolation fault between the rings. So I will check all of these connections as well, because maybe this is also a problem with a short circuit somewhere in that power supply that occurs while the board gets warm. This is a thing I will do off camera, replacing all the capacitors here, and this one I have ordered a new one because this is these capacitors are a bit bigger than usual. But I will show you the other board from the spare power supply where the capacitors are removed. This is here. I could show you maybe the damaged part. Yeah, there is it. So there was the capacitor, the lead capacitor, and here the circuit board is a bit damaged due to the fluid that went out of the capacitor, but I've measured it. It's still okay. It's only the a bit of the isolation on the top. Although I do not have to solder in a bypass when I will use that board here, because when I replace the capacitors of the other board, and the power supply will still switch off after a while, I will use that board with the new capacitors, because I think because this capacitor was completely broken, yeah, this is the reason why this board did not start to switch, and then the whole power supply does not turn on. And here there are the capacitors from the 7 capacitors. You can see here there is a bit of the leaked capacitor, but this is the only one from that from that board. So I will now will desolder them off camera from the other board, and will check the other board as well. Yes, I've replaced the capacitors on both boards, so you can see both boards here. The way to separate the spare power supply from the other one is on the main power supply, from the power supply from the VAXserver. There are the optocouplers are white, and from the spare the optocouplers are black. So and also there is some kind of marking on the back on the metal piece. It's another way to separate them. But now new capacitors on both boards, and I've checked everything, so the orientation is correct from all capacitors, and I've measured the capacitors. These capacitors over here are from that board, so I have to flip them around. So that board here, and this is the 1000 microfarad capacitor here from the filter capacitor from the primary side logic, and on that power supply this was okay. So I measured all capacitors with the LCR meter, and all capacitors are okay. So I don't think that was the issue with that board, or that causing an issue, but I will try that board first and try if the VAX will turn on, and when the VAX is still turning off, I will try that board and hope that that board will work again. And when the power supply, when then the VAX will running for a longer time, then I know that the issue is located on that board, but not the capacitors, but maybe something else is broken. So first of all, I will build that board back into the power supply and will try everything, but I will do it off camera because when it works, then I will do a recording, an next scene recording after a longer period, but I will do a lot of tests off camera, and it's a lot of work to record everything, record every step. So therefore, you will see the result in the next step, but between the next scene and the actual scene, maybe there will be some time and some more tests that you won't see, but I will tell you about that tests and things I did in the time between the two scenes. Now it's several weeks later, and I wasn't able to fix the power supply, so all the things you've seen before does not change the behavior of the power supply, so the power supply still turns off after a random time. And then I've changed the logic board from the other power supply, with the other logic board from the other power supply. The power supply did not even start, so therefore I think I'm not able to repair the power supply at the moment. This is because I do not have the right measuring equipment for it. I need isolation transformer and differential probe for the oscilloscope and extensions to do measurements while the power supply is running on my desk outside the VAX. And this is more complex than I can handle at the moment. The only thing I could do is randomly take out parts and measure them or replace them, maybe on the logic board that won't start, replace the PWM controller and stuff around it, just to change things. But at the moment, the VAX 4300 cannot run because there is no power supply. And you see here on the left running VAX, the VAX 4200. I made a separate video that you can find that video on the main channel, where I put the system disk from the VAX 4300 into the VAX 4200, because then I have a running VAX. It's quite ugly, but it works. And this is also then the end of my first video of this junk channel, and I hope you found that interesting, and I hope you see you in the next video on this channel or on the main channel. You can leave comments down below, also follow this channel and leave likes here, and so on and so on, and see you the next time. Hello viewers, welcome to the first video of Idioten.